Hi, I'm Kazi. So we are presenting a data analytics platform for health devices. This is a B2B platform where healthcare device manufacturers can register their devices for data aggregation, visualization, and inferences. The platform supports of streaming data coming from different kinds of devices like headbands, smartwatches, different biometric sensors, and different kind of devices. The manufacturers can also set recipes or policies that govern the inferences drawn from the incoming data.
So this is where the different rules and policies of different health devices are being set. For example, if you are a headband manufacturer, then you can set a rule like if the body orientation of the person who's wearing the headband is greater than 175 degrees, this means that the person is lying down. Or say for example, you are a wrist Fitbit or a smartwatch manufacturer, then you can come and set the parameter like if the number of steps that the person is taking who's wearing the smartwatch is lesser than 35, this means that this person is having a sedentary lifestyle. So this is where you can store the different rules or policies according to your devices. There is also the option of uploading your deep learning or machine learning model through this platform, which will then be applied to the data which will come streaming in from the actual devices into the Kinesis data stream. This is hosted in AWS. As far as persistence of the data is concerned, if you see here, we have connected a Postgres database to it, and if you see the most recent two rules that we just added have been added to the database.
See here, we have simulated a headband user and a Fitbit user. Both the devices are continuously sending data to our streaming platform. The two dynamic graphs to the right illustrate the continuous flow of data, which will be used in the future for predictive modeling and other analysis.
This is where we have our application. On the left hand side, you can see data is being written into the stream, and on the right hand side, the same data is being taken and being stored into the database. This is the back end. On the front end, we have the same data. Here it is being represented or visualized. The data which is being streamed in is presented here. On the right hand side, we have the add rule. So what you can do here is you can set a recipe or a rule according to the device and according to the parameters that you are recording. For example, right now if you see, this is the heart rate and it is showing a normal for 80. So let's do something, and high when it's more than 100. So let's set that, let's set a rule which says that if the heart rate is more than let's say 70, then we'll call it risk, and let's submit this. So this rule gets stored in the database and immediately is being retrieved by our system here on the left hand side. And now you see, instead of high, the word risk is coming. Same thing we can do for the second parameter, QRS. Say for example, we choose the parameter as QRS, and if the value is more than 70, or yeah, more than 70, we call it too high. Okay, so and once we submit, again, now if you look at the window here on the left hand side, you will see that it gets updated and it will show too high from now onwards. So this is how we are updating rules live and showing them, implementing them on our data set. And you can see the different parameters here, including the heart rate and everything being shown here in these visualizations, which are coming from the live data directly.
Of x-rays in your local machine, and you want to put them to good use. You want to train a model that automatically detects whether an x-ray shows the prevalence of the disease or not. All you need to do is zip the existing images into two files, one for containing the images of infected x-rays the other containing the images of the non-infected ones. Next, what you need to do is you need to upload them to the application. So you choose the ones which are infected and you choose the ones which are non-infected. You give the name of the disease and you train your model. You will see the model appear in the list of models for your system in that application. If you see here, heart enlargement has been added to the end of the list. So I choose a couple of models like heart enlargement, COVID, and dengue. Then I choose the image on which I want to apply these models, and I want to test what is the percentage of the disease being prevalent in that x-ray. When I click on submit, the image is passed through those models, and as an output I get the percentage of the chance of the disease being there.